Assalamu alaikum. I'm Khalid Saifullah Mehdi. The last four digit of my ID is 1050. Our open-ended experiment name is Design and Simulate 4-bit ring counter. My other team members are Prakash Haldar and Fahimur Rahman. At first, I want to say about the objective of this open-ended experiment to design a 4-bit ring counter using Cadence software to understand the working principle of sequential circuits, especially flip-flop based shift operations, to observe the behavior of a single active state circulating through the 4-bit register, to perform schematic design and analyze circuit functionality through simulation, to develop basic understanding of VLSI design flow, including schematic layout and verification steps. This is the circuit diagram of 4-bit ring counter. This where we use 4 flip flop, which you can see in this picture. Truth table and working principle of a 4-bit ring counter. A ring counter is a type of sequential circuit made using flip flops connected in a shift register Sequester form. In a 4-bit ring counter, we use 4 flip-flops where the output of the last flip-flop is feedback to the first one, forming a loop or ring. At the beginning, we initialize the circuit so that only one flip-flop is in the high state. For example, 0001. When a clock pulse is applied, this one shifts to the next flip-flop. So the sequence becomes 1000, then 0100, then 0010, and again back to 0001. This process continues with each clock pulse, meaning the single high bit keeps circulating through all flip-flops in a fixed pattern. So in simple terms, a ring counter works by continuously rotating one active bit through a series of flip-flops using clock signals. We can see the schematic design of 4-bit ring counter, which is made by NMOS and PMOS. We know NMOS and PMOS uh, combinedly make CMOS. Now I request to my next team member, Prakash Haldar, to continue the presentation.
Hello everyone, this is Prakash Haldar, ID last four digit 1039. Now I told what is ring counter. A ring counter is a type of sequential circuit, especially a circuit shift register where the output of the last flip-flop feedback into the input of the first flip-flop. Here we see the picture run Ashura VLSI and select library and cell technology must be select GPDK 090, then apply OK. Next, next picture. This is show the ring counter. A ring counter is a type of the image show the sequential symbol for a D flip flop. Within an electrical design, automatically software environment likely a tool using for integrated circuit design of VLSI. Here in D data, the main input logic level present at this pin is captured and transferred to the output on the EDG on the clock. And next clock, the control signal, the triangular icon indicate the EDG trigger and the output Q. The primary output represent the stored state. and Q bar, mm, the complementary output, which is always the opposite logic level of Q. Power VDD, the positive power supply PN, and it's ground, the ground of reference pin. Now I summarize the function. In digital logic, a D flip-flop acts a basic memory cell. Whenever value is on the D line and is latch and hold on key unit, the next clock pulse. This make a fundamental following block diagram. Next slide. The image show a schematically for testing a D flip-flop within an electrical logic designed automatically (EDA). Software environmental likely cadence virtuoso. Now I brief the circuit. The schematic the schematic include the following primary component. Here is the D flip-flop block. The center component labeled D flip-flop within standard input and output. Here D data input, clock clock input, Q main output, and Q bar complementary output. VDD and ground the power supply and ground connection, and voltage source. Here V0 the voltage source providing power to the VDD terminal, and V1 and V2 there are the pulse voltage source based on the wiring. One is likely generated the clock signal and the other is generated the data input signal. And the output pin. Label pin for Q bar, Q and Q bar are used to observe the flip-flop state during simulation. একটু পরের ছবিটা দেখাও। Based on timing diagram provide the transient response simulation. This circuit behave a positive bit trigger D flip-flop. Here is an analysis to how the signal interact. Here clock green color. This is the clock signal. It has a provide period of 50 nanosecond, and D red color. This is the data input. It changes state more frequency than the clock, and Q the purple color. This is the output. Notice that it only changes its state at the rising edge, the opposite edge of the cell signal of the clock signal, and a Q bar. This is the complementary output, always showing the inverse of Q. At last, I told the output Q capture the value of this sequence when clock transient from low to high. The image represent a positive bit trigger D flip flop. Thank you. Now I give the place Faimur Rahman.
Hello everyone, my name is Mohammad Faimur Rahman. My ID is 1049. First of all, we see the result of the layout design. Layout design steps: draw CMOS inverter, build transmission gate, combine to form D flip-flop layout, copy the DFF 4 times, connect output in ring form. Provide VDD line, GND line, common clock line. Simulation steps: set clock pulse, set initial condition, run simulation, and observe outputs Q0, Q1, Q2, Q3. The conclusion: the 4-bit ring counter was successfully designed and simulated using Cadence software. The experiment demonstrated the cyclic shifting of a single active state through sequential flip-flops, confirming the correct operation of the circuit. Through schematic design, simulation, and layout attempts, a better understanding of sequential logic and basic VLSI design flow was achieved. However, limitation in the layout stage highlighted the need for further improvement in physical design and verification skill. Thank you, sir. That's all.